Everyone, for this week in BIN501, we're going to try to pull data from the American Gut Project. Or actually, in this particular case, I think these are actually COVID samples, but we're going to try to pull biosample survey data from the website directly without, visiting on the browser. And we want to be able to do this for multiple files and then get a summary. And so everything in this assignment is really just practicing mechanics that are going to be useful for your final project. And there are a lot of different ways to do it. And I'd like you to figure out, what way makes the most sense to you. But I thought it would be helpful to have a video that just walks through one possible solution. So if you get stuck on any of the steps, you can kind of get over that hump. So in this tutorial, we have, I've given each of you a single report to pull down from Biosample. I pulled down as an example in the RPub 312-807-75. After you pull down the one, and do keep pulling down the one as part of your script, I want you to rewrite the script to be able to pull down 8 different reports. And those text file reports are going to all be structured in the same way, so they can be pulled into a single list that is a set of data frames that all have the same questions and responses. And you get an idea with this nice small data set on how you could automate the process of looking through survey data when you're pulling publicly available data from NCBI Biosample. And it just makes the process a lot easier. Just like with the RPubs that you saw that was for a single identifier, we're going to load the same libraries. We're going to use rvest and dplyr. Just really helps kind of organize things. But unlike that RPub, we're just doing, a single set of data. We are going to want to create an empty list so that we have a place to put as we go through a for loop, or you can use a while loop, you could use sapply, you could use map, there's a lot of different ways to do this. But as we go through that list of different websites that we're going to visit, we want a single place to store them in the environment. So instead of reading data from a single web page, we're going to read data from a set of web pages. And the big change here is just defining a number for each of the web pages, those unique NCBI biosample identifiers. There's a couple different ways to do this here. I just did a for loop from 1 to 8, and then I added that number 1 to 8 to a set value to equal the identifiers. That worked well because all these IDs are in order. Another thing I've done a lot once I have more IDs is made a text file with all the IDs and then read it in. So you can do it in lots of different ways, but once you have some way to iterate across those different identifiers, you're going to go visit the page, type out the name of the page, visit the page, import the page, and break it up based on the HTML tags using dplyr and rvest, and then add it to the list. So here, I use that same identifier. I just converted it to a character to be the name of the list. This is helpful if later I want to find out which host, which sample went with which piece of data. So once I run this, it just takes a few seconds to pull all of those 8 websites down. I now have a list, and each of the list, the name of the list item is that unique identifier, which does also just help you map back to the website. And for every one of these, there are 11 questions in the survey. So it's much shorter than the American Gut Project survey, and 11 questions and 11 responses. So you have all this data in one place in your environment, but to be able to pull from it, you might want to use sapply. There are, again, many ways to do this. You can do this with loops. You can do this with map, but I liked how clean sapply was. So I pulled the vector from each of the elements in the survey data list responses by using sapply and pulling off the second vector not question, but response. that exists in each of these tuples, so the second column. And then I pulled ages out by looking at the 9th element in each of those individual vectors. So if we look at the table text, just so you can see it, you can see that the 9th element is host age. I could modify this for any of the questions. So I could do isolate source, and I could make a pie chart to look at all of a summary of the responses for that one question. So I did this for 2 different responses. I made a pie chart of the response. When you make a pie chart, you're often wanting to do something similar to a histogram. You're trying to look at the frequency. So it helps to run this table command before you run the pie chart. It just gives you a chance to see like how many responses there were for each of, or how many samples had each type of response. So if I run this, you just run this code chunk and then this code chunk, we can look at the table and you can see like, okay, 50, 56, 58, 59, most of the ages, there's just one person, and there's 2 people who are 84 years old. Pie chart looks pretty even, except for that one slice of the pie that's 84. We can do the same thing for genders, again, using sapply, but now genders is the 10th question in the survey. So it's that 10th element. And if we look at this, now we get a really simple pie chart. So you are welcome for this assignment to do any of the columns, any of the questions in the survey. I just wanted to walk you through this possible solution so that you can start to think about how to make your code work well for a relatively small number of samples, but future-proof it so it would work for hundreds of samples. And I think that using things like sapply, it's a lot more robust than sort of like walking through every single possible variable or doing anything where you're like explicitly calling the elements in a list. You really want to build something that like automatically, no matter how long the list is, creates those vectors, creates those variables that are then going to be plottable.